Okay, so now we're going to actually get to the logarithms, and you'll see why we were playing with those exponents. No, not that kind of log. No, not that kind of rhythm. Silly stuff. No, instead we have a little rat that says squeak. I wonder if that's going to have any relevance as we go on. Okay, again, this is available on Quick Schools. I've got it both as a Word document and as a PDF. It is that wonderful exponent table. So again, what did we have the previous day? We had a 7 to the third power is 343. Sure enough, if I look at the base of 7, I look at the exponent of 3, I see how that lines up with 343. Say, oh my goodness, 7 to the third power would be 343. So again, this exponent table maybe will help out for those of us that just don't have these numbers dance in our heads, right? Some of us, they just magically dance around and we say, oh, I can do this all in my head. And some of us are like, whoa, what's going on here, Scoob? And so this table helps out. Okay, so definition of a logarithm with a base b. Now, b has to be a positive real number. Y has to be a positive real number. And we're not going to use 1 for the base, because if the base is 1, it's really not exponential, right? Because 1 raised to any power is 1. So the logarithm of y with base b is denoted by log base b of y, and defined as log base b of y equals x if and only if b to the x power equals y. Now, if this seems like a bunch of mumbo jumbo, wait till we play with a couple of numbers and then it will hopefully start to make more sense. All right, and of course the expression log base b of y is read as log base b of y. So in logarithmic form, log base b of y equals x. And then if we want to talk about the exponential form, b to the x power equals y. So first, let's just see if we can rewrite them back and forth, see if we can get any kind of sense out of this. So that's in log form, right? It's log base 2 of 8 equals 3. So what is that trying to tell me? Well, I know the base is 2, and the exponent is a 3. It's telling me that if I have 2 and I raise it to the third power, I get 8, right? 2 times 2 is 4. 4 times 2 is 8. That's what that is telling me. Let's look at a different example. What if I've got log base 5 of 25 equals 2? Okay, now again, the base is 5. The exponent is 2, all right? That number all over there by its little lonesome, that's the exponent. 5 to the second power is 25. Right? I'm just rewriting them right now. It starts out in log form, and I change it to exponent form. Log base 7 of 7 equals 1. Okay, so I said log base 7, so the base is obviously 7. The exponent is going to be 1. So 7 to the first power equals 7. That's what that was telling me. I think one more example fits on this top line, right? Log base 3 of 1 equals 0. Okay, now again, notice when I read it, I say log base 3, so that should clue me in that the base needs to be the 3. That number way over there by its little lonesome, the 0, that's the exponent, right? The log is telling me what the exponent is. So 3 to the 0 power equals 1. Rewrite in logarithmic form. Okay, so what if I start out seen something like this. Oh, I got an exponent. 4 to the second power is 16. And I want to rewrite this as a log. You know, again, the base is 4, right? The exponent is 2. So this is going to be log base 4 of 16 is 2. Log base 4 of 16 is 2. Right? In other words, if I'm looking at the number 16 and I want to use the base of 4, the exponent has to be 2. 8 to the 0 power equals 1. Okay, the base is 8, right? So it's log base 8. Then I got to remember to put the 1, so log base 8 of 1. I'm basically saying, hey, if the base is 8 and the answer was 1, what was the exponent? Well, the exponent had to be 0. 8 to the 0 power makes 1. 6 to the first power equals 6. Okay, the base is 6. So log base 6 of 6 is 1. There we go. One more example is going to fit on this line. 2 to the 5th power is 32. Okay, the base is 2, so it's going to be log base 2 of 32 is 5. In other words, hey, if I'm looking at the number 32 and I know I'm in base 2, what on earth was the exponent? Oh, the exponent was 5. So some of what we want to do is just kind of go back and forth and rewrite them. It's kind of like in elementary school, if a teacher said, hey, 4 times 5 equals 20, you would rewrite it as 20 divided by 4 equals 5. Or if a teacher said 3 plus 9 equals 12, you would rewrite it as 12 minus 3 equals 9. Same thing. It's kind of like playing with the number families from elementary school. Find the value of x. Okay, now these are fun questions because there's 3 different places I can hide that x. Right? I can either have the x be the exponent, or I can have the x be the base, or I could have the x be the value of the number after the base is raised to the exponent. So, what's going on here? Well, log base 3 tells me that the base is 3. The exponent is x, and I'm supposed to come up with 81 somehow. So 3 to some power has to make 81. Well, 81 is 9 times 9. I wanted a base 3 though. Oh, each 9 can be written as 3 times 3, right? 81 was 9 times 9, but 9 is 3 times 3. So it looks like I've got 4 of those 3's. So 3 to the 4th power makes 81. So x is 4. Right? If I've got the number 81, and I know the base I used was 3, the exponent had to be 4. 3 to the 4th power equals 81. Again, you can also use the exponent table. Log base 2, 1/8 equals x. Okay, let's see, the base is 2, the exponent is x, and I'm supposed to get 1/8. Well, how does this happen? Well, I know 8 is 2 times 4. Oh, and 4 is 2 times 2. So I've got 1 over 2 times 2 times 2. So that means the exponent has to be -3. Right? Because there's 3 2's, but they're on the bottom of a fraction. So I've got 2 raised to the -3 power. X has to be -3. Log base 49 of 7 equals x. Okay, so the base is 49. The exponent is x. Somehow I got to come up with a 7. Well, I know 7 is the square root of 49. And of course, square root is the same as the half power. x has to be 1/2. Okay, let's see if this is where the x hides in different places. Yeah, this is where the x starts hiding in all sorts of weird different places. Now, I know that the base is x. I know the exponent is 3. I know the answer is supposed to be 64. Now, there's some traps I can fall into. Right, I could try 8 times 8 for 64, but I needed 3 equal factors, not 2. I also know that 64 could be 2 times 2 times 2 times 2 times 2 times 2, but that's 6 equal factors. I only want 3. So what I really need to do is I need to take that 64 and use 4 times 4 times 4. Right? So if x to the third power is 64, I must be talking about 4 to the third power is 64. So x has to be 4. Now, again, for those of us who don't have these numbers dancing in our heads, if I look at the exponent table, I'll notice there are many different places 64 shows up. Right? 8 squared is 64. But I don't want squared, right? Because I've got x to the third power. 2 to the 6th power is also 64. But I don't want to play with an exponent of 6. So I got to make sure that I pick a 64 where the exponent is 3. And then I say, oh, 4 to the third power makes 64. Right? So that's how that exponent table can come in and help. Because sometimes it's a no-brainer, right? If I give you 49, you're thinking, hey, what can I do for 49? 7 times 7, right? Nothing else is going to work for 49 except for 7 times 7. But some numbers like 64, oh my goodness, there are all sorts of choices. Right? So that's why this exponent table might come in handy on a fees. Log base 9 of x equals 2. This is actually the easiest of the bunch to figure out when the x is in that location, because you know the base is 9, you know the exponent's 2, so what is 9 squared? Well, 9 times 9 is 81. Right, so that's the actually easiest place to solve when the x is just sitting right there. Log base 8 of 64 equals x. Now again, tricky time because you're like, whoa, 64 can do all sorts of tricks to us. But not so much this time because the base has to be 8. I don't know the exponent, but I know 8 to that exponent has to be 64. Well, 8 times 8 makes 64. So it must be 8 squared, right? So x has to be 2. Let's do a few more examples and then we'll turn you loose. Okay, I don't know the base. Exponent is 5. Answer is 32. Again, if I needed to, I could go to the exponent table and underneath the exponent of 5, I can go looking for that 32. And I should say, hey, guess what? It's a 2, right? If I take 5 2's and multiply them together, I get 32. X has to be 2. Log base 7 of x equals 3. Again, we're on easy street with this type because you know the base has to be 7. You know the exponent is 3. All I needed to figure out is what is 7 times 7 times 7. 343. I think we got one last example. Log base 6 of 216 is x. So 6 to some mysterious power equals 216. And again, I can almost use that exponent table if I need a little bit of help or guidance. Or I can use some sort of a guess and check thing. But, 6 times 6 is 36. Well, that's too small. 36 times 6 is 216. Bingo, we got a winner. Third power. All right. So have at it. Got a worksheet. And we never did find out why we had a rat that said squeak on that first slide. Bizarre. You would think that squeak had something to do with this lesson.